Welcome to In 5 Minutes. We take problem on simple stresses and strain and we consider tapering bars. A problem statement is a uniformly tapering rod of length L and diameter small d and capital D is subjected to an axial pull P. Show that total elongation of rod is delta L, which is given as 4PL by pi capital D small d into E. So consider a rod of length L whose diameter is increasing uniformly from small n diameter small d to big N diameter capital D. So this is a form of a conical section. We have shown the front and side view of the same uniformly tapering rod, which is subjected to an axial pull or tensile force P. So for this bar we have to show that the total elongation due to this applied tensile load is given by delta L equal to 4PL upon pi capital D small d into E. So let capital D be diameter at large end, small d be diameter at smaller end, L be the length of the bar, and E be the Young's modulus or modulus of elasticity of bar material. The dimensions of all respective parameters being as shown. Now, solution. We apply elemental approach to solve the problem. Consider a small element of the bar of infinitesimal length delta x and at a distance x from smaller end. So this is a small element on this bar which is at a distance x from the small end and of length dx. This dx is very small, so we can assume the small element to be a section. The diameter of this element is given as d plus capital D minus small d by L into x. We see that capital D minus small d by L represents the change in diameter per unit length of the bar, since the diameters are changing uniformly. When we multiply x to this term, we get the change in length of diameter from the smaller end. So the diameter of the element at this section at a distance x from small end is equal to d plus capital D minus small d by L into x. Now the extension of the small element due to axial load P is given as P into delta x upon pi by 4 into d square, where d of the small element is given as small d plus capital D minus small d by L into x, the whole square multiplied by E. Since we know the formula for elongation or extension is given as delta L is equal to PL upon AE, so the length of the small element is delta x and area of the small element is pi by 4 into d square. So now the extension of whole rod or bar will be given as integral of this term from the length equal to 0 to L. So we see that this term is of the type 1 by x square, whose integral will be given as delta L is equal to integral from 0 to L 4p upon pi e into d plus capital D minus small d by L into x, the whole to the power minus 2 into dx. So now taking the constant terms out, we have delta L is equal to 4p upon pi e into the integral of this term will be d plus capital D minus small d by L into x to the power minus 1, the whole upon minus into capital D minus small d by L in the limits 0 to L. Now again taking this term over here, we have delta L is equal to minus of 4p upon pi e into L upon capital D minus small d into, now upon applying the limits to this term, we'll have our first term will be d plus capital D minus small d by L into L to the power minus 1 minus of d plus capital D minus small d by L into 0 to the power minus 1. This L and this L gets cancelled. So in the first term we have, also this d and this d gets subtracted. So in the first term we have capital D to the power minus 1, and if you see the second term, this whole term gets cancelled and we have only small d over here to the power minus 1. Now writing this two diameters in the reciprocals, we have minus 4p by pi e into L upon capital D minus small d into 1 by capital D minus 1 by small d. Now we invert these two terms so that this minus sign get cancelled. So we have delta L is equal to 4p upon pi e into L upon capital D minus small d into 1 by small d upon 1 by capital D. Now upon cross multiplication we have delta L is equal to 4p upon pi e into L upon capital D minus small d into capital D minus small d upon capital D into small d. Now we see these two terms gets cancelled. So now the delta L becomes 4p into L upon pi e into capital D into small d. So this is the expression for elongation of tapering rod subjected to a load axial pull P. With this, our problem is over. Thanks for watching in 5 minutes.